Hi everyone, I'm just gonna wait a couple seconds to make sure you can hear me. If you can, please type in the chat and I will look to make sure everything's working. Hello everyone. Perfect. Great. So I'll go ahead and get started. If anyone else joins in, thank you for joining. My name is Heather Shapiro. I'm a technical evangelist at Microsoft. Today I'll be talking about an end to boring data, a way to make your visualizations better in Python. And if there's any questions throughout, please type in the chat. I have another window open, and I'll try to answer them. I'll be going back and forth between code and presentation, so please bear with me if there's any technical difficulties. So you can find me online at MicroHeather on Twitter. And if you're wondering what a technical evangelist is, I like to say we're geeks who speak. Essentially, we're developers who don't have a product team. We go around and we talk to startups, students, developers in the community about technology, trying to get them more involved with it, teaching it to them, etc. So let's get started. What are we going to talk about today? So we'll talk about why data visualizations are so important. We'll look at a case study on New York City restaurant ratings. We'll look at what libraries in Python work best for different types of graphs. So this is kind of a look at my journey throughout Python and getting more into data visualizations. So it's not all the libraries that are available, so I'm definitely open for suggestions if anyone knows of others, but it's just the ones that I found best and which ones that I did not like as well. So there's a lot of reasons why we need data viz. It's super important because data can be very hard to understand. It's, if you take a look at this Zilber cartoon, Lindsay helped Colin, she jokes, I put together a spreadsheet that might interest you. He's like, oh my gosh, it's so boring, it hurts. And she's like, yeah, this happens a lot. So data itself is extremely hard to understand. So if you just present spreadsheets to people, it can be very difficult for people to read the story and get to know what is actually going on. There's also too many numbers. So like I said, it's hard to understand, but if you just present someone with a whole data table with thousands of numbers, they're not going to have any idea what's actually going on. And just as a side note, I like to use GIFs, so hopefully they'll make you entertained. Another reason why data viz is so necessary is because you always see them in meetings. So you always see spreadsheets in meetings, and your manager will talk about it and be like, oh, look at the spreadsheet, look at all these values, and you see these pivot tables, but they really aren't helping anything. You don't understand what's going on, and they make the meeting super unengaging. So using data visualizations can be a great way to enhance your meeting, make sure that your teammates are engaged, and make sure everyone's actually understanding what's going on. Because you always see in meetings people's eyes glass over, or they're always on their computer, and they might not be listening. But if you have these entertaining or interesting visualizations that people are able to understand, it makes it a little bit easier for them. So we've also seen that there's examples of visualizations when they've gone wrong. I just looked up online bad visualizations. So sometimes we'll see pictures that have too many variables. So you might see a visualization like this, where you really can't understand what's going on in the picture or in the graph. So we're looking at 100 most active tweeters. And active tweeters, we don't know what that means. Is it active tweeters, people who have the most followers, people who tweet the most, people who are retweeted the most? We have no idea. We also see that there's tons of different colors that look extremely similar. So you really have no idea what this graph is telling. We see this one person does have a lot of active tweets, but who is that person? Then we have different variables or different graphs that might look like this. There's no title, there's too much going on, and while they try to make an intricate graph, it's not easy to understand and can make it extremely difficult for a user. I've looked at this graph tons of times, and I still have no idea what it's looking for. So data visualizations, as we mentioned, it helps the visual learner. So for those of us who don't like to just read numbers, it presents it to us in a more visual way. It also just makes it easier for participants in general. So if people can look at colors that are interesting to them or graphs that are easy to understand, it can make sense of tremendous amounts of data. You can walk through a problem with people. So if you're trying to show like a time series data, or if you're trying to show time series data, and you're trying to show a point that from 1950 to 1970 there was a huge dip, showing it in numbers isn't really going to help. If you have a graph, in just in seconds, people can understand what is going on. So things that are part of a good chart. You want to keep it simple. So we saw a few graphs that are really difficult to understand. There's too much going on. So when there are visualizations that have too many variables, there are different ways that you can go through them and display them. You might have tabs, you might filter them. So that's one way. There's also, outside of Python, there's different tools like D3, which make it a little bit more simple as well. But you want to keep it simple so that people really understand what's going on, and they don't have to look and try to think really hard about the graph. You also want to sort your data. So if, like I mentioned, if we're looking at time series data, you don't want to put your data from starting at 1970, then to 1950, to 1960, and have it all over the place. You want your data to be in chronological order, or in an order that makes sense to your story and to your reader. You want to use colors that connect, so if all of your colors are similar and there's no differentiation between them, it can be extremely difficult for them to differentiate and to figure out what's actually going on. You also want to make your visualizations easy to compare. So we've all seen those economics papers or different papers that will show you graphs and say, look, last year, this is what the data looks like, and this year, it looks completely different, like we're having this complete increase. But then you look at the axes, and it's completely different. So they might have moved the axes up 10 figures, or they did a regression, or they normalized it somehow, and all of a sudden your data you're not comparing apples to apples, you're comparing apples to like bicycles. And so they say, look, these are so different, and at first glance, you might think that, but now as a reader, you have to go in and say, okay, wait, are we actually looking at the same thing? So you want to make it easy to compare, and this might be something, I guess, that if you're doing marketing or if you're writing a paper, you might not want to make it easy to compare, but now at least you can be cognizant of that. Know that people are doing that on purpose so that you'll get a different story that they want out of it, but it might not be the correct story, or it might not be the correct data. You also want to make good charts personal. So if you're in a meeting, make it something that relates to your members. Don't just show them a random graph. If you're looking at Twitter users, maybe show it on Twitter, or have different visualizations that are added into it, so it's just not a boring graph. When you make it personal, you can also use all the other things of keeping it simple, sorting your data, but having titles. So having a title at the top, having labels for your axes, having labels for different colors. That makes it easier for users to understand. So these are all just certain things that I think are very important for a good chart or visualization. There's definitely different ways to look at it, and there might be other things that you think are important. So it's kind of to everyone teach their own. So today we're going to look at a case study on New York City restaurant ratings. So I'm based in New York City, and when I go out to eat or I'm looking for food, I realize I'm like super hungry, and I'm like, what do I do now? And I like look for all the food, and then I'm like, oh, which place is actually great? So I'm going to play a video for you. Let's hope that the sound goes through. That's how I feel about restaurants. Thanks for this, man. Oh, hold on. I think we have. Turn that. I think we have a little bit of sound issue. Apologies, everyone. Sorry. I'm having a little difficulties with the sound, so I'll figure that out in a second. But essentially, if you've ever seen Parks and Recreation, Ron Swanson goes and he's like, this is my favorite restaurant. And they're in a bowling alley. And they're like, wait, aren't you afraid of the food? And he's like, well, it's the food that should be afraid of me. And as I'm walking around New York City, that's not how I want to feel about my food. I want to know that what I'm eating is healthy, or at least the restaurants are clean. When I walk around and I see things with like no rating or a C or a D, I'm like, oh my gosh, like what have they done? So I think I actually got it working now, so I'll just quickly play that so you can. Thanks for coming, man.
Of course. This bowling alley is my favorite restaurant in Pawnee.
Really? You're not scared to eat here?
When I eat, it is the food that is scary.
So that's always a fun example. So where did I get this data? So New York City actually has thousands of open data sets that are online. And I'll quickly switch over to that site. So we can see that there's thousands of different data sets. You can have business, government, education, and there's tons of these. And when I was looking through, I saw that there's this one for New York City restaurants inspections. So we have all of the different restaurant names, their boroughs, building, street, it's a bakery, inspection date, what was wrong, codes, etc. We also see what scores they got. And there's tons and tons of data. So on this website, it's really cool. If you want to go and play around with it, you can. You can also do different visualizations on here, which is really cool. You can look at a calendar, you can look at charts, maps, all different types. But we're going to take a look at this data inside Python. So switch back. This is kind of what the data set would look like. It's an example. So we have in there, we have the inspection date, like I said, actions, violations. You don't really get a lot out of it. And then here's a quick video explaining what the actual New York City restaurant ratings are. So if you've ever been to New York and you haven't seen this, it's a good example of what is actually going on, or it explains what's going on so that people get a little bit more context here. So hopefully I'll play that. If you have issues hearing, please type it in the chat and I will try again.
Recently, the New York City Health Department started getting all restaurants, bars, delis, and bakeries letter graded as routine sanitary inspections. What we're doing with restaurant letter grading is taking a score which was hard for people to interpret in the past, putting it in a simple form, the letter grade A, B, or C, and in a place where people could see it before they choose to dine at that restaurant. We started the restaurant letter grading program for two reasons. unexpected illness. We first got the idea of restaurant letter grading from Los Angeles, and after they instituted putting letter grades on the front of restaurants, they saw about a 20% reduction in food-related illness. That's a big health benefit that we think we can do here. And our inspectors go to restaurants, they inspect everything from whether or not they have the sink for people to wash their hands, to the temperature of the refrigerators, to whether the food is left out, to whether there appears to be good preparation services, to whether there might be evidence of light or cockroaches. And establishments with scores less than an A have the opportunity to improve their grades. If a restaurant gets a B, it has to go to B, we'll be re-inspecting in about 6 months. To get a C, we'll be inspecting in about 4 months. The first restaurant to get an A in New York City was Mark Deli. 24,000 restaurants, that was the first one. We love this place because it's clean, it's meticulous, it always has a tremendous variety of wonderful foods and hot meals, and it's obvious that it's a clean place to anybody that comes in here. There's a lot of restaurants you walk into, they don't look desirable. Meaning that we have to look at their pantry. Most citizens, when they pass by a place, they don't know what's going on in there. I want the schools to be okay. I want them to be happy with these kids. And I want them to be sick and angry, and the guys deserve an A, because they have people cleaning up and mopping around all the time. To show that in any restaurant, the corner deli can have good food safety practices. So we were very proud of this.
So that was just an example, or them explaining why they do it. So it's really nice that we have that in New York City. So now I go around, when I see these lower letter grades, I'm like, okay, maybe I should stay away from these places. And I don't have to hungrily eat my food, and I can actually have some sense. So it makes me a more concerned citizen, I guess. And it's just like using what's out there to be able to help myself. So today we're gonna work in Jupyter Notebook. So if you haven't seen Jupyter Notebook, it's a really great tool that allows you to write code in line in the browser. You can run it locally. I'm actually running it in Azure. So if you are interested, you can do it on your own if you can't install Python on your computer or Jupyter Notebooks on your computer. So Azure actually provides these notebooks for you. So you just have to have a Microsoft account. And so you can actually write code in line. It's pretty cool. And one of the great things I actually just learned yesterday when I was finishing up everything is that you can show slides on here. So I'm going to try that for today. Let's see how it works. So if you haven't worked with Jupyter Notebooks, one great thing is you can just write code and it'll show you the answers. I can just keep doing 5 times 2. Yes, and it writes it in line. So if you're looking to debug, it makes it a little bit simpler. If you want to put breakpoints and you don't actually want to learn the debugging tools, this makes it very simple. And it's I code in this most of the time. So some of the steps that we take today, we're going to look at how to load modules, how to load the restaurant rating data. How do we understand the data? So, okay, so we have this data set. Can we look at what's there? We already saw it online, but now let's try to understand it through visualizations. Some people use this for an exploratory analysis. So oftentimes for me, so I study statistics in school. I like to think of hypotheses. Okay, so I start with one question. Today, when I look at this data, I want to see, okay, are the scores and the grades the same? So for the restaurant rating data, the scores are from 0 to infinity. The higher the score means the more violations that you had. So if you have a score of 10, that's better than a score of 50. And usually they like to say that 20 and below is an A, 20 to 40 is a B, above that is a C, pending is P, so that means that they haven't gotten their rating yet, and Z just means that they don't have a rating at all, and they have to come back. So I wanted to see, okay, so we have these letter grades, and we have these scores. do they match up? Are there any inconsistencies there? And you might think that this could be a problem in case like the inspectors are going through and maybe they know the people and they aren't giving the correct scores, or maybe there aren't enough rules or regulations that are in place to figure out these scores. Maybe it's not consistent from different bakeries. So I wanted to look at, okay, we have this data. Can we figure out if where scores or grades are highest or lowest? Can we see if they're consistent with each other? So I really just wanted to explore this data. So if you want to take a look at this later, I have a GitHub, and I'll share out these links as well. And on the GitHub, it has the data already. It has this Python notebook, and it will allow you to walk through it. You can put your own data in there. You can download the restaurant rating data, but I also put a curl line in there so that you can actually download it from my Dropbox. So I'll have all these links afterwards, and you can see that. Okay, so some of the libraries that we're going to take a look at: Pandas, Matplotlib, Basemap, Folium, Seaborn, Boca, and Plotly. So these aren't all the tools that you can use. There's tons of others, or these are sometimes built on top of others, and they have different requirements and different prerequisites, so they'll install all of their things. These are just the ones that, at first glance, these are what I found. Some of them I like, some of them I dislike, and I'll walk through how to set them up to an extent, and what you can do with them, when you would use them, and whatnot. Okay, so getting started. Pandas. So if you haven't heard of Pandas before, you can look at this cute little GIF of Pandas falling down. It's my favorite. But if you haven't seen Pandas before, it's a Python library that allows you to do data analysis. It's built on top of NumPy, SciPy, and Matplotlib, which are very big scientific or computing libraries that are in Python that allow you to do data analysis. It gives you series and data frames, which make it much easier. So if we go back to this slide, so first, actually, to go back to import libraries and data, it's pretty simply just to import NumPy, Pandas as PD. So I just wanted to name the different things. For Matplotlib, I wanted it to be in line, so it didn't open in a new page. So that's just one thing. Okay. So Pandas, when you want to look at Pandas, so we're looking at this restaurant CSV. It's pretty simple, actually. So PD stands for Pandas. So I have this CSV that I installed with a curl line and passed it over in here. So I named it, scroll back, New York City restaurant data. Got cut off, but okay. And all I have to do is say read CSV, and I can now make it restaurant. So then I realized there's tons and tons of data. At the point when I downloaded it, it's actually being uploaded all the time. At the point when I downloaded it, there were hundreds of thousands of points in here. So I wanted to limit it just to boroughs in Manhattan, the borough of Manhattan. So all I have to do is say, okay, let's take a look at the restaurant Pandas data frame. And now let's check, okay, so let's get only the restaurants where the borough is equal to Manhattan. And now I have this MREST data frame that is only boroughs in Manhattan. Now if I take a look, you can see that all of them are Manhattan. So it narrowed down a lot of what was in there. And if I want to see what other columns there are, it's really awesome for Pandas. You can just say .columns, .values, and it shows you all of these different columns that you can have. So we have, like, again, we saw this before, zip code, building, street, and it shows you how they're written. So now you can easily reference them. Okay, so just a little bit of data cleaning on my end. I wanted to get rid of the ones that weren't graded. If they did have a grade, I don't want to look at them because I can't compare grades and scores if we don't have full data. So I also wanted to get rid of the null values. Okay, now all I have to do is pd.notNull. So anything that's not null in the grade column, let's keep. Anything that wasn't null in the score column, so which means we actually have a score. Usually this is going to coincided with not yet graded, but it didn't always. So I just wanted to get the cleanest data that I could. Let's take all the data that has grades and scores and compare them. So we can see that in what I have now, we have 84,000 data points. And we can see the mean score is about 13, which means everyone's doing pretty well, but the max is 131. So there are some that really have bad scores and grades. And so standard deviation is about 8, which means there's a lot of variance in this. But it was so easy for us to understand this with Pandas because now all we had to do is say .describe, and that's super simple. Then I did a little just reordering. So like I mentioned before, we have to order our data. So I made it ordered as A, B, C, P, Z. Otherwise, Pandas just puts it in as the order that it got. And it has no leveling. So I put it in that way. And like I said, all of this is in the GitHub. So if you want to follow along, you can do it there. GitHub.com/Heather B. Shapiro. Okay, so now we've made all that data cleaning, and we can just do mrest.head, and I just did reset index so that it wasn't all the values weren't just like 0, 10, 20. I wanted it to be in order so that when I index it, it's the normal value that I would think. So I can do 1 through 10, and it will show me everything. So all I have to do is mrest.head, and we see this data frame. So in the past, when you had CSVs, you often had to, or without Pandas, you would have to read in the CSV file. You would have to go line by line and say, if it's this, then add this. But Pandas just makes it so much easier. Easier to reference, easier to index, etc. Okay, now we have plotting with Pandas. And we'll take first a little look at matplotlib, which Pandas is actually built on. So libraries for statistical graphs. So like I said, matplotlib. If you haven't heard of it before, it's a MATLAB-like plotting framework. So if you've used MATLAB, maybe in school or at work, there's a bit of a learning curve for how to actually install, how to get used to MATLAB-like coding. So if we go back, when you use matplotlib, you have to write, okay, so we want subplots, we want score, we want frequency, label, all this. And it's kind of a lot of code just to get a basic bar chart. But this goes along with what our description was before. So we did .describe, and we saw that most of them, the mean was about 13. So this coincides with that. Most of them are about 10. But in Pandas, the code is a lot more simple. Since Pandas is built on top of matplotlib, we can change the colors. So these were different colors that you chose. So I just did the colorblind one to make it easier. Oops, sorry about that. So all I had to do was score.hist, how many bins I want, and then you plot that title. And in much less code, I was able to get basically the same chart. Okay. So if we look at it a little bit more, I didn't put titles for these. I apologize. I have to do that. But we see the grades. We can do pie chart. So with matplotlib, you would have to write a lot of code, but with Pandas, it makes it so simple. You just do, okay, for all the value counts, do a plot of grade, and now times equals pi. So I want a pie chart. And you can look up what values are. And we see that this is actually using matplotlib. So like I said, it's built on top of matplotlib, and it's built on top of NumPy. It's using all the things that other people created for us. We see the grade, A is the highest, B is next, C, P, and D. So do all these actually deserve A's? It kind of funnels my question a little bit more. Do they all deserve A's? Like, there's a lot of them. Why do they all have A's? We can also easily do a bar chart. So there was a flag on there, so were they critical, not applicable? So I wanted to see, okay, do any of the ones with A's or low scores have critical flags? If they do, why do they still have an A? Does that mean like they're going to get reevaluated? Whatnot. Okay, Next one I want to take a look at is Seaborn. So this one is, Seaborn is a great tool that's also built on top of Matplotlib, but I think it creates a little bit more sophistication in your graphs. It looks more professional. And I see that some of the stream is buffering, so please let me know if there are any issues with that. So Seaborn is, like I said, built on top of Matplotlib, looks more professional, and all you have to do, it takes a little bit to just look up what kind of plots there are, but I say, okay, I want a strip plot, and I'll show you what that is. X equals grade, the Y value, so the Y-axis is score. So for every grade, let's look at the score. Data is MREF, and then jitter equals true. Switch back here. And so we, like I said, we can import it, but without jitter means that you don't get to really see how many values there are. So with this, you kind of don't understand how massive this data set is. MREF has 84,000 points, but in this, you can't really tell. So when we add that jitter equals true, you can kind of see the massive data here. But what's nice about this, when we go back to our original question, we see most of the A's are less than 20, which is what they should be. But then there's a lot of C's that are less than 20. You're like, wait, why? Or what about all these ones that are between 20 and 40? Was that like the inspector? So it just gives us more questions, more things to look into. So I added that critical flag. Okay, so some of them weren't applicable. I don't know why, but most of them are at least not critical under the A category. But there's a few here that are critical that are low scores. So this is just something if you wanted to follow up with the people who are making these reports. Why are these critical? What was that? So now I have more questions that I can ask, and I can lead more into a data problem. So there's all different types of plots that you can do. So there's box plots. You just have to say that you want huge critical flag, and it does it all for you. So there's box plots. There's excuse me, bar plots. There's so the bar plot, you can have it look like this. It's all the same, you just change this one little part. And it still kind of shows you the same data that we saw before, but now we have all these different options. Okay, so next step before we look at converting long, let's take a look at libraries for mapping. So the first one that always pops up when I do research is Basemap. I found it pretty difficult to install. It might be easier on a Mac. I haven't done it on a Mac, but on my Windows computer, it's a little bit difficult to install. So if you do have a Windows computer, please contact me and I can show you how to do it. I figured that out. But there's also a lot of prerequisites that came with Basemap that I had to install, and it wasn't just part of the DLL. And the documentation wasn't there for my computer. So you would think to install one of the most popular libraries would take maybe an hour. It took me a full day to figure out how to install this on my computer. I had to like come back to it. So it was pretty challenging. So that was a little bit of a negative towards Basemap when I first getting started. For others, it might be easy and take 1, 2, 3. But for me, when I was looking at this as a beginner, like this is really difficult. Like the barrier just to start with it was huge. Okay, so Basemap, that's the kind of graph you get. But before we look at what kind of graphs you get and why you need and how much like code goes into it, I had to convert all the addresses to lat long. So I'm going to show you some code that I wrote to do that. So I worked through, I used in Flex. These are just some messages I found. I had to look at all the strings. So, okay, so if someone in one place wrote the one first street, but they wrote it with the number 1 as opposed to the written word 1, that could be very difficult. So I had to put all this, I had to make a mapping of all these words to numbers and do it that way. Then I also had to go through, so I had to iterate over this for every single value in my data set. So it became difficult, so if you have to do that for your own data set, please just feel free to use this code. I also had to, sometimes I'll have first street instead of first, or one instead of first. So there's tons of different variations of what people could write. And that's just one of the inconsistencies with data, is the data cleaning. It takes so long to do this and made it so much more difficult. So I was able to make them normalize, and now after all my code, East 9th Street, West 51st Street, they're all written the same way, and it made it so much easier. And even if it's at the beginning, so 5th Avenue, that's the same. So now it's a little bit more consistent, and I can put it into an engine to geocode. Okay, so I wanted to take a look at the same data every time, because looking at this data, 80,000 employees on a map is going to be extremely difficult. So for this example, I just used 100. So every time I rerun this, it has set seed equals 10. If you set seed equals 11, it'll be a different value. It will be the same exact data. This way I can compare every time. Anytime I make a change to the values, and anytime I make a change to the code, I'll do the same thing. So I wrote a lot of code to try and geocode these addresses, but API limits were very difficult. So I actually found this website that will do batch geocoding for you. findlatitudeandlongitude.com. And all I had to do, excuse me, I wrote a file out as text. I copied it all into this input, and then it gave it to me as I can choose it. I can download it as CSV or just copy and paste. So I was able to write this, so all the addresses it wrote out. And now I had this address.csv file, and I was able to read it in. It has latitude, longitude, etc. Okay, so now let's get back to base math. So we have, all this data, but with the restaurant ratings, addresses, geocoded. So now if we look at a map, we actually have this data. So that was like a lot of cleaning just to get to this one step. I was able to figure out an easy way. So in Jupyter Notebooks on Azure, might not be the same if you're running a local. You can just do Pandas install base maps, and that made it a lot more simple. But before, Notebooks on Azure is actually pretty recent. Before I found this, I was doing it locally, and I had so many issues. I had to import base maps. Okay. So there's a ton of just learning that you have to do to be able to understand what's going on. So I had to look up what the latitude, longitude is for New York City, look at what kind of projections there are. So that's just basically what the map will look like, resolutions, where you want to start. This was a really difficult part for me. I had to look online at different websites to figure out what I wanted to be. So this is the lower left corner longitude, upper right corner longitude, lower left corner latitude, upper right corner latitude. And I had to manually do those values. And then I had to draw coastlines, draw countries, etc. And all I got was a graph that looked like this. So one of the problems with base map, it's much better for world data or geo data. So if you're looking at thermal data across the globe, it's much better. But it doesn't have that granularity to be able to do cities or specific street addresses. So I was pretty disappointed after doing all this work, writing all this code, and all I got was something that looks like this is apparently New York City. So base map might be good for all those other scenarios, but it wasn't good for data like this. And I could have gone in and added in my own map in the background so that it would have that as the boundaries, but that would have been extremely, extremely difficult and taken a lot of time. You can do that, and you will be able to get this granularity, but to be able to find those from OpenMap or MapQuest, things like that, it's very difficult. So I then kept looking for more, and I found this great tool called Folium. It allows you to visualize data on a lakelet map, and it has tile sets from OpenStreetMap, MapQuest, Open, Mapbox, all different things, and it makes it super simple. So with Folium, all I had to do was install Folium. It's actually pretty simple. It looks like a lot of code, but first I would say import Folium, okay? And then I say I want to map from Folium the location. So this I did still have to look up. I wanted to start at the center of New York City. I played around with the zoom start, so that's just like how far out you want it to look. If you want it to be really zoomed, so if you're looking at a country versus like a little city, you might play around with that. And then the nice thing about Folium, I'll show you this in two ways. I was able to add clusters. So all I had to do is say, I want the values to be clustered. And then I walked through all the samples, the whole thing of the sample. And so I looked, okay, for every grade that has an A, go through, this is looking at the latitude longitude, so put a marker at that lat long, give it a pop-up. Then I said, also give it a score, write the name, and show the grade, and then we'll color icon. So it looks like a lot of code, but you're essentially just saying, okay, here's the lat long, and this is what I want the pop-up to look like, and this is what I want the icon to look like. So I did that for A, B, and everything else. And I get this awesome graph that looks like this. So much better. I can zoom in, it clusters. If I click on this, it says the name of the restaurant, what their score was, what their grade was. Can do that. If I zoom out, does it all over. I can zoom out even more, and it all clusters. So all I had to do was add that one cluster line. Oh, I lost it. Add that one cluster line, and it changed everything. So now I have this great visualization. And if we look at it without clusters, so I just removed that one thing, didn't change anything else, and now I have a map like this. So when you have more data points, so then with only 100, and you can see it's extremely condensed. It's pretty difficult to understand because there's just so many data points. So that's why having clustering on the map would be great. Okay, so the next one we took a look at, I wanted to see interactive plots. So I like to blog at microweather.com. Haven't updated it recently. Been pretty busy traveling, but I wanted to figure out, are there ways that I can make my website better, make them more interactive? Can I embed this into an app, or can I embed this into something that I'll show my manager that will be really cool, and it's not just that simple graph. So all these graphs I've shown you were great for specific purposes, but sometimes you want that more interactiveness. So one that I found is called Bokeh. Bokeh is pretty simple to install. Sorry, actually, to go back to Folium, Bokeh also has this as well. You can actually just save that graph as an HTML, and you have all that code. So I'm talking about interactiveness, so now I can embed this map into my website because I have that HTML code with all the data already in it. So Bokeh allows you to do that too. So it's pretty simple. You just say import Bokeh. These are the graphs that I wanted. Histograms, I'm only going to look at mainly histograms right now. So I did histogram as simple as score. And now I get a graph like this. I can move it around, zoom in if I want to, box zoom, data. So if, say my axis is really small, it might make more sense if you wanted to look really closely to see what the difference is. So I can keep zooming in, which is awesome. You can save these, reset it. There's tons of different things you can do. So pan through. Reset. And there's also a question mark that'll show you that. Bring you to Bokeh website. One problem that I did have with Bokeh was that yes, they showed you all of this. They bring you to this website and show you the data. But when I was first looking at it, before I actually figured out how to create a map, there's tons of different versions. So the documentation wasn't always the easiest to understand. Sometimes I'll look something up, and the search results will show not the latest version, and I was trying to do it, and you're like, oh, this is deprecated. Like, so difficult. So once I figured it out, it was much easier, but having that question mark there after I figured out the plot was a little bit difficult. So also, I can now look at color, I can look at titles, legends, etc. And now I have a graphic overlaid that has different colors, and we have a legend, so they're pretty different, so it's easy to understand. You can zoom around, you can zoom in. So if we zoom in really close, this might be a time when you want to see, okay, so this is scored by grade, sorry. Now I reset, and that makes it a little more difficult. Okay, so we have the score based on, this is basically just the frequency. So for every score, how many do we actually get, and what was their grade? So, okay, so we see mostly if the score is less than, like, here is about 12, 14. Most of them are this A color, and they're pretty high. If I zoom back out, you can see it's pretty high. But then there's those few in there, and zoom back in, they have their P's, or there's a P, or the C. The colors get a little bit more difficult because they're overlaying, so when you're looking at colors, that might be something you want to change. So it just gives you more questions to ask. You can also have tabs. So we were talking about making your data simple. So if we want to do frequency and score, or if we want to do it by grade, add different things for people to easily compare, it makes it so simple. And like I said before, you can easily just put this into your graph or into your website. You just have to save it as an HTML, and now I have that HTML code. So the last one that I wanted to talk about is Plotly. So Plotly is, there is a paid for version, but I just use the completely offline one that I don't need, that I didn't need a user login for. Didn't have to use anything. So there is that free tier. And the only difference really is if you want to publish it to Plotly, you can make it private if you pay for it. So having it online, if you want to make an account with the free tier, you can still embed it places. You can embed it easily to WordPress. You can embed it to your website. But you can make it private. So for people who need to have that internal, or people who need it to be user authenticated, you don't want to put it publicly, and you have to pay for that. But it's pretty simple. Import Plotly graph. I just found some lines, and I just said, let's do it offline. Download all Plotly notebook, and file. Okay. So the code is a little bit longer, because there are more integrated graphs, and integrated meaning they're interactive. There's a lot more that goes in the back end. It might look the same as the other ones, but there's a lot more that you can do with it. So learning this took a little bit of time as well, but I can just say, okay, I want histograms where the X value is X is grade. I want it to be probability density. There's tons of different ones, so if you're interested in statistics, you can go look up what the different histogram models are. Then I wanted the bins. So for me, I wanted the bins to be, okay, so from the minimum to the maximum, figure out a dictionary there. Okay, so we have title. So the layout, I say, okay, title, I want to auto-size it. Here's the difference between bar gaps in between, the height, width. This is just customization, and you can look at that. And I say, put this into a figure. Okay, so now I have this graph. And when you scroll over, there you can see that it's, you can get the values. When you zoom in, it's better. I don't have to click to zoom. I don't have to click that button like I did before in Boca to zoom out. It just automatically does that. I can scroll back and forth. zoom back, pan, zoom in, zoom out, auto scale, reset the axes. So if I do that, it will show you what like the closest value is. Let's see, compare data on the timer. There's not really much data to compare, but then if you want to say produce by Plotly, it brings you to this website. And you can then export it to Plotly and log in, etc. So I found these a lot more useful for a website. So I tried to do the same thing. Now I just do it before, but I changed different values for like the bar gaps or the bin. So it's also different there. So I told you about this formula here that was like, okay, let's take a look at the minimum, let's take a look at the maximum, and then create a dictionary between the first score. Now I have slightly smaller bin size, different things. So before, we had grades, come back out. These just have wider bin size, so now there's a lot more variability in the score. It's a lot more, it's 0 to infinity. And for this data that I pulled, I only had up to 35. Okay, so last thing, also, you can do it differently. There's just tons of different ways you can modify it. So what I just did with happening in all the other things, I said trace the data, and then I'll have this figure, and it does it automatically. So if you don't want all that customization, you can still do what you want. Zoom in, you get that same variability there. Okay. So then I tried to see, okay, can I use Plotly for math? It's so great for other visualizations. What about for math? There's tons of code that I tried to write. A lot of it is just saying, okay, we're looking at USA, looking at states, looking at here's the lat long, text markers, what markers that. So it is still customization, just what we want. But you get a map that doesn't have that granularity. And it's also interesting because for some reason, you can see that one of my data points is all the way out another state. But if I zoom in anyway, we can put this little scale. So that's kind of nice. If I zoom out or zoom back in, let's see if we can keep going in. Oh, so hard. Okay, so we can at least see the state, so it's a little bit better than it was before. But this is as far as we can zoom in. So you can't really understand what's going on. So Plotly was great for creating interactive graphs that you put into your blogs, but it's not really great for granular local data. Okay, so the closing thoughts, we talked about a lot of different libraries here. Pandas. You need Pandas if you're doing data science, if you're looking at data at all. It's handy, it's simple for plots, but you do need to be willing to learn the Matplotlib to be able to customize it a little bit. So it's definitely useful. You definitely need it if you don't want to import a CSV and actually have to read through every line. Matplotlib, we talked about before, is difficult to learn. There's a learning curve, but since Pandas is built on top of that, that's where all the customization comes in. So Seaborn, we also talked about, it supports more complex visualizations, but it requires Matplotlib, so it's still, if you want to make it even more, it's customizable, you'll still have to learn that. But the color schemes are a really nice bonus, and they make them just like look so much more professional. So when you're looking to create a PowerPoint for work, or for your blog, or just anywhere you want to share data, Seaborn is really nice because it has those color schemes, and you just need one line of code and it gives you everything. The base map we talked about, I told you how hard it was to install on my local machine. Online it was fine, and it had to do a little curl, but it wasn't robust enough to have that high granularity that you need for local data. So if you grade for heat or thermal data, geo data across the world, you need to compare, but it wasn't great for county data, city data. Then we looked at volume, which I thought had the best documentation of what I had seen. One thing, just me being picky, is it might be there and I just couldn't find it, but maybe if they had more interactive widgets. So like if you think about Google Maps or Bing Maps, you can filter on things a little bit more. So what if I only want to look at the A's? Show me just the A's. Can I add that interactive widget? That would be nice. Maybe if you're looking for an open source project and you want to contribute to Folium, that could be something you could add. But Folium was great because it was simple. I didn't have to do anything really other than find the latitude, longitude of New York City, and then it created all the data for me. Boca, once I finally got the documentation down, it was pretty good. It's nice interactive, but I thought it was overkill for simple scenarios. So if you want to make your website better, I might go with Plotly instead, but Boca is still a great tool because it does have that different tabs. You can do things like that, but it's just a lot to learn for just a simple scenario. But the nice thing about it was that you can give that HTML code. Then there's Plotly. It has the most interactive graphs. You can scroll over and see what the values are. You can zoom in. You don't have to actually click the tools at the top. You can save them offline. Create these rich web-based visualizations for your blog. But like we saw for mapping, it wasn't good with city-level data. So while it had its pluses, it also had its minuses. So this was just, I wanted to walk through all these different libraries, show you, okay, if you're looking at just basic graphs that you want to show into a report, put in a paper or bring it to a meeting. There are certain libraries you can use for that. If you're doing mapping, there are certain libraries. If you're looking at your website and you want to make it better, here are some interactive graphs you can use. So to go over briefly what we discussed, we talked about how to look at data visualizations in Python, how to walk through a data problem. So I started with this one question about restaurant data. Okay, are scores and grades the same? And we saw that there was some inconsistencies there. Not a ton, but there's something more that I can go and look into if I wanted to. We looked at what libraries are useful for what purposes. And we learned how to update your blog to make it more attractive that users might want to stay on and understand what you're talking about. So I found the resources that you can find. So if you look at it, we get out of Heather Shapiro and then go to it into foreign data, you can find all the codes that I just walked through today. All the data was from New York City Open Data. So you can go to that website. If you don't live in New York City and you're interested in your state or wherever you are in the world, there's tons of open data sets across the world, US. I found ones for Boston. I found ones for Toronto. I found ones all over the world for places I've been, and wanted to look more into the data. There's also data.gov, or there's things like Kaggle where you can download data sets and work on them. So if you haven't heard of Kaggle, Kaggle is an online kind of competition for some. Things like Netflix data. When Netflix put a data challenge on there, they wanted to create the best recommendation engine. They put their data there and they offered a grand prize, probably a couple 100,000 million, I don't know what it was. They offer money for the best response. So there's competitions, but then there's also easier ones that aren't for money, aren't for a prize, they're just so that you can learn, pat yourself on the back and say that you learned something. So things like the Titanic data set are on there. You wouldn't necessarily use these kinds of visualizations for that, but a Titanic data set, can we compare who survived the Titanic versus who didn't, and we know that like women and children were on there. They were usually escorted off the boat first, but can we narrow that down to see like what the data shows for that? There's also, if you can't install this on your computer, if you're doing a work computer, there's also a data science virtual machine in Azure. So if you go to ak.ms/data science VM, this data science VM has R installed, it has Python installed, It has tons of different resources installed that you can look at. Also, if you're just interested in learning about statistics in general, Azure Machine Learning is a great tool that's in the browser, drag and drop tool that you drag your data set in, and then if you know the basic data science process, if you put in the data set, you clean it, you sample from it, then you apply an algorithm. So if you're trying to do predictive research, you can play around in Azure Machine Learning. You don't have to do any coding. You just have to drag and drop. So say I want to try a logistic regression versus a regular regression. Now, in Azure Machine Learning, I can just drag them in and see what the differences are. And there's also tons and tons of resources on Channel 9 and Microsoft Virtual Academy that you can look at to get more into data science, to get more into data visualizations as well. One last one that I wanted to show is a little bit, it's not in Python, I mentioned it earlier. Let's go to D3.js. So D3 is a great tool that has interactive plots that you can put in your website. There's tons of interaction. There's a huge learning curve, which is, in my experience, has made it very, very difficult, but there's tons of different options. So that's just an option if you're interested. Okay, so if you want to contact me, please feel free to email me at hshapiro@microsoft.com. Find me on Twitter, follow me, go forth the repo, or ask me questions. If you want to make any pull requests, please do. I'm open for suggestions. If you have any other libraries that you really like for visualization, please let me know and I can take a look at them. But thank you so much for taking the time to listen about how to onboard data with your visualizations. It's great to learn, and it's a great tool. And when you see these kind of visualizations in your meetings or in reports, you really understand a lot more of what's going on, and you can tell a story. So thank you again, and I'm so happy that I could spend this time for Highlands remote. Please ask me any questions if you have. So happy to present to you. Have a great day, wherever you are. Thank you.